So looking at motion problems. $31st. Alright, so I'm going to label this A. So, how fast did this person walk in segment A? So, how fast did they walk in segment A? Can everyone see it? Good. So, how would you figure this out? So, speed, this is looking for speed. So, speed is equal to distance over time. What distance do they travel in? How far do they go? So, they started at 10 feet. So, they started at 10 feet. And moved to 30 feet. So they started at 10 feet and moved to 30 feet. So what was the total distance? So what is the distance they traveled? So the distance is equal to 20 feet. So 30 minus 10. And how long did it take? 20 minutes. So what is their speed? Their speed would equal 20 feet divided by 20 minutes, which is 1 foot a minute. So very, very slow. How fast are they moving during this segment? So the speed would be 0 feet per minute. So they tired out. That was very hard. Moving 1 foot a minute, painful. They did it for 20 minutes. Y'all try moving as slowly as possible for 20 minutes. but But you get that we have to look at the starting position and the final position. So this is a total distance of only 20 feet. And then we look at the starting time. Starting time is 0. Final time is 20 minutes. Also, pay attention to units. If I had just put miles per hour, they're moving 1 mile an hour. That doesn't make sense because the graph is in feet per minute. So let's do another example. How far did they travel in segment A? How far did they travel in segment A? They're saying 30 what? So their speed is 30 meters per second. So they're moving at 30 meters per second. Remember, the first thing you need to do when looking at a graph is understand what the graph is talking about. This is talking about speed. So this is saying for 20 seconds, so in other words, putting in words, we could say a car is moving at 30 meters per second for 20 seconds. This is what the graph says. So remember, how do we solve for distance? We're trying to solve for distance. So speed is equal to distance over time. You can draw your triangle if you want it. So we're solving for distance. So even though we're doing graph problems, you gotta memorize the equations and still use the equations in solving it. So distance is going to be equal to your speed times your time. Or speed was equal to 30 meters per second. Our time was 20 seconds. And so that is equal to 600 meters. So they traveled 600 meters in the first 20 seconds. What is the car's acceleration? During segment B. Another way of looking at this, look at segment B, and just imagine it's a car. Putting this into words, it would be a car began at 30 meters per second and decreased its speed to 10 meters per second in 10 seconds. So we need to look at our equations. Our equation is final minus initial divided by time. So if we're looking for acceleration is equal to change in speed, final minus initial over time. Its initial speed will be this point here corresponding to 30, and where units are meters per second. Its final speed, so its final at this point, is 10. And its time would be the length here between 20 and 30 seconds. So it would be 30 minus 20, which is 10 seconds. So plugging that into our equation, that would be 10 minus 30 divided by 10. So that would be negative 20 divided by 10, which will give us negative 2. And our units would be meters per second divided by second. So meters per second divided by seconds, which is the same thing as negative 2 meters per second squared. So it's losing 2 meters per second every second. Yes. Alright. So when looking at a distance time graph, slope is equal to speed, or velocity. When looking at a velocity time graph, slope is equal to acceleration. Have y'all ever done slopes and looking at graphs before? That's all you're basically doing. You can plug it into the equation, or you can just look at the slope. The equation is the slope formula. So looking back at this original question, we see a rise here. We see a rise of 20 feet. And we see a run of 20 meters. So the slope of this line is just 1 feet per minute. Because it's the rise of a run. Or you could just look at speed is equal to distance over time. For this one, again, we know that the equation for acceleration is change in velocity over change in time. So if change in velocity or rise had went down by 20 meters per second, and our run changed by 10 seconds. So it would be a rise over run. This would be negative because it went down. So it would be negative 20 over 10, which is negative 2 meters per second squared. So rise over run. Mm-hmm. So this image shows a student walking to class. How long did it take to reach the classroom? $50? Who says 50 seconds? Who says 60? So notice that here they stopped. So they're no longer moving at this portion. If we come and look, they stopped at 50 seconds. So we have to assume that they reached the classroom here. So here they're walking to class. The office calls them. They turn around, go to the office, and then continue moving back to class. Well, here they turned around and started facing it. So it'd be 50 seconds. And let's make this point. I didn't draw it correctly. Let's make this be 35 seconds. And this be 20 meters. I'll label this A, I'll label this B, and I'll label this C. So again, it's kind of hard for me to just sketch this accurately. During segment C, how fast was the student walking? So again, we can look at rise over run, or we can look at the fact that speed or velocity is equal to distance over time. So we can see from here to here is 15 seconds. And from here to here, I'm trying to make this represented with 20 to 50, so that would be 30 meters. So the distance would be the final point minus the initial, so that would be 50 meters minus 20 meters. The time would go from 50 seconds minus 35 seconds. So change in y values over change in x values. So that would be 30 meters over 15 seconds, which is 2 meters per second. Yes. I tried drawing it at this line. Sorry about that. Let me draw it like that. I know it's slightly off. I was trying to get it like that. What is the total average? What is the average speed? So average speed is equal to total distance over total time. So the total distance, looking at here to here, would be from 0 to 50 meters. So we do 50 minus 0. Then we look at total time, 50 seconds minus the starting time of 0 seconds. And so that would be 50 meters divided by 50 seconds, or 1 meter per second. How far away was the classroom from the starting location? That's easy. By the way, for the people at home, the code word is derivative. The code word is derivative. Actually, he's still moving forward. This is velocity. He just slowed down slightly. Well, he's still moving forward. I'll label this A, B, C, D, E. Alright. When, assume this is a graph of a car. When was the car stopped? Which segment? So it would be the segment HI. That's how you should draw a segment. The two letters will line above it. Or you could do H-I, either one. When was the car accelerating? So anytime the line isn't flat, so A to B, C to D, E to F, G to H, and I to J. When was the car not accelerating? Or I should say, moving at constant speed. So that'd be B to C, D to E, F to G. I should say. Let me cancel this out. So when was the car moving at constant speed? So H to I, is he moving? No, so he's not moving. And so J to K. If it said when was the car not accelerating? It's almost the same thing, except for we would include HI. It's a constant speed of 0, but he's not moving. Does that make sense? So here, so H to I is you're not accelerating, you're not moving, your speed is constant, 0. but you're not moving. So here is not moving. Speed is 0 meters per second. So yeah, pay attention to what the words are saying. So how would you put this in words? If this describes a car. So the car does what for the first 4 seconds? The car speeds up from 10 meters per second to 30 meters per second for 4 seconds. Holds its speed. Yeah, that's okay. Holds its speed of 30 meters per second for 2 seconds. Slows down to 20 meters per second and holds that speed. Gasses it to 50 meters per second. Meters. I said it. I just didn't write it. And then slams on its brakes. Stops temporarily and then gasses it up. So do y'all think y'all got graphs down? And it's the same thing we've been doing. We just have more stuff going on. The important thing is to make sure that you know what graph you're looking at. Technically this would then continue. So the plan is tomorrow I'm going to do a test review. We're going to have a test Wednesday. Did everyone finish the homework? What? Oh, okay. Yes. That's it for the day.